All right, in this lesson what I'm going to do is go over our first set of SQL commands. You'll get to see me run the SQL in the Oracle SQL Developer Interface and just get going on this. So for this example, I'm going to create a table. In your assignment, you'll be uploading the tables that are in your SQL statements that are found in Canvas, so that way you can work with the TAL database, the Colonial Trips database, and all those other ones throughout the semester. But what we're going to do is we're going to go over basic commands for creating tables, putting values into tables, and just some other things. And so I'm going to copy and paste code in because it's painful to watch me type this, especially because it is very tedious, the typing for this. And so what I'm going to do is I'm going to run some SQL that's going to create a table that's going to have a customer number, which will be the primary key. We'll have the customer's first name, last name, their address, city, state, zip, their phone number, their cell phone number, their email, and then we'll have a rep number. And so while we're doing this, we'll be able to talk a little bit about setting up field names. We'll talk about the data types that we're going to use. Highly recommend that you review the notes in the PowerPoint that I've added to data types. It's very important, and I'll talk through some of those, but not all of them here. So I'm going to go ahead and here in the window, notice I have my connection set up. I don't have any tables yet. When you run yours for the databases in the books, you'll have tables there. But I'm going to go ahead and paste in this code. And hopefully you can see this because the code's not very easy to see. But we have the create table command, and then we choose what we're going to name our table. Then we open up parentheses, and don't forget to close your parentheses at the end. It's kind of like those curly braces in your programming language. If your parentheses don't match up, then you're going to get errors. And so notice as we go through, I do have some errors in this code, and I'm going to run it and try to talk you through that process. So we have our create table. We have the name of our table that we're going to have, and then we have our field names, their data type, and then any other attributes that we want to add it. And each of these are going to be separated by commas. So in this one, we're going to add a field named customer num. Notice the underscores. Your field names can have letters, numbers, and underscores. They have to start with a number. They can't have spaces. So custom is the field name I've made up here. It's going to be the data type character, and I'm going to have it be 14 characters long. Depending on how big my customer number database is, that might be too big, it might be too small, but again, that would probably be determined by the actual business that I was working with. I am going to set it as the primary key of the table by adding the designation of primary key and then a comma. So our next field we're going to do is first name. It's going to be character that's going to be 15 characters long. And I'm going to put a constraint on it that this field has to be filled in. It cannot hold null data. The rest of our fields down here can, but these first two fields, first name and last name, cannot. Then we're going to take their address, which is a car 20, city, car 15. Now, when you're setting up these links, you need to be careful to make sure that they're long enough. If you had state to where they were spelling out the whole state, you need to figure out what's the longest state and make sure that your data field accommodates Mississippi. Don't just think about Texas, okay? But in our case, we're actually going to have car 2, so we can store the state abbreviation. Zip code. So here's the first one where we're going to have this be car. Just like our customer number, Parrish have talked about it, but we're going to talk about car. So zip code for Stephenville is 76401. Why would I want an alphanumeric, and why would I not have a numeric value for that? And the answer is, in database design, we have a lot of fields in our day-to-day lives that look like numeric data, but they really aren't. I would never add my zip code to somebody else's zip code to get an answer. I would never add my student ID to somebody else's student ID and get an answer that's actually useful or worthwhile. So the rule of thumb generally is if it is not going to be used in a calculation, then you're going to go ahead and store it as alphanumeric, is either in the CHAR or the VARCHAR. Now, you need to read the difference between CHAR and VARCHAR. I'm pretty sure I asked you a question about that on the midterm, or maybe on one of the homework assignments, but there are differences. Review that in the PowerPoint or in the textbook. So again, phone number is the same thing. We would never add a phone number together. So even though it has numbers in it, we're going to go ahead and make it an alphanumeric. We're going to have our cell phone, our email, again, making sure that, that might not be long enough, but we're going to hope it is. Then in this table, we're going to have a discount rate. For some reason, our customers get a discount based on who they are, maybe. And this is the first of our numeric data types. We're going to have a decimal because it's a percentage. We're going to store it as a 2-digit decimal or 2-digit number. And 2 of those numbers are going to be after the decimal point. So in this case, we're going to have something from 0.01 to 0.99. We're probably never going to give somebody 100% discount on something. That's called free. Now, what I don't have here is a data type that is an int or small int. So you need to review those as well in your textbook and in the notes. Integers are non-decimal numbers. They have ranges. Small int covers smaller numbers, and just regular int has very large numbers. When you're choosing that data type, you need to make sure that the range of possible values is going to fit within the data type that you select. Birthday, we're going to save it as a date. Notice we don't have anything in parentheses like we do with all of our other data types because date is a set format. And then down here, rep num, we're going to set that as CHAR 4. So a couple of things to note. Create table customers. All of the fields you're going to create are surrounded by parentheses. So on the end here, you're going to end up with a double parentheses because there's a parentheses for the CHAR 4 and then the closing parentheses for the whole statement. Now your SQL statements also need to end in your semicolon. So let's talk a little bit about the interface here. Notice that this right here is what's highlighted because I've been clicking around so much. If I click the play button or the run statement, it's going to run the statement that's highlighted. This environment allows you to type statement after statement without having to reset it. You can just do one after another, highlight what you want to play or run, and click that button up there. So what happens sometimes until you get used to it is you won't pay attention to what is highlighted, and you'll come up here and you'll click run, and you're going to get error because it's missing a right parentheses, but realistically it doesn't know what the heck you're talking about. So again, like all programming languages, the error messages at first might not be that useful, but once you get used to it and once you make a lot of errors and have to figure out what they are, you're like, oh, I get it. So let's go ahead and highlight our whole statement and click the run statement. And I still get errors. And so again, you come down here and it tells you at line 12, column 1, it looks like there's a problem. So you could go through this, but notice also here in the editor, it has little squiggly lines, kind of like you see in Word when it's trying to tell you that there's a problem. And when you highlight over it, it says there's a syntax error and that it expected something. In this case, I've just forgotten the commas in between these fields. So I just need to come in here, put my comma in. I'm missing one here also. I know that just because I've run this code before. And so now when I highlight this and run it, I get feedback down here that my table customers was created. Okay, so another thing to know about the interface here, over here under tables, it still looks like there's not a table there, but it just told me it created one. There is a refresh button that you have to hit after you run certain SQL statements. So when I hit this, what it's going to do is it's going to update it and show me that there now is a customers table there. And so when I click on that table, it shows me the names of the fields that I've created. I shouldn't have data in this table. I'm not sure why I do. Let me refresh that. I don't. I was from an old iteration of this. So you shouldn't have seen that. You should come up blank like this. Now up here along this area, you're going to look at the columns or you're going to look at the data. Most of the time you're going to want to look at the data, but generally speaking, you're going to spend most of your time here in the worksheet area. And so once you create the table, you can actually write SQL that shows you the data in the table down here, and we'll get to that in just a minute. Right now, our table doesn't have any data in it. So what I'm going to do is I'm going to insert, I'm going to write an insert statement that is going to put some data into our table. You don't have to have multiple lines, but I do it just to make it a little bit easier to see. And so what I'm doing here is I'm inserting into the customer table these values. So if I don't list fields here, it's going to automatically match up the first value with the first field, the second value with the second field, and on down the line. So if you are going to fill out every field, you can just do insert into customers and give the values. Notice some things in our statement here that I want to point out. All of those car values are going to be surrounded by single quotes, kind of like string data in a programming language when you have to put into quotes. You're going to do the same thing here in SQL. Notice our numeric value 0.05, which is my discount rate. It is not going to be enclosed in single quotes because it's a numeric value. Now this one right here is a kicker. We're going to use Oracle throughout the whole semester, and so this is the format that you use for dates in Oracle. You use the date, and then the 3-letter abbreviation for the month, and then the 4-letter year. And it's surrounded in single quotes. Now, date formats in other databases this is not something that's standardized. So if you're using SQL Server or you're using MySQL or something like that, then you're going to need to check to make sure that you know what data format you're going to be using. So what this insert does is it takes the values and puts it in. Now in the real world, a lot of times your data is coming in from other applications, either other programs, websites that are gathering information from forms. This is if you want to hard code values into your table. So I'm going to highlight that and I'm going to run that, and it's going to tell me down here that one row was inserted. And so if I want to see that, I can click on my customers and I can go to the data. Now nothing's there. It also has a refresh button. So if I refresh, then I'm going to see the customer data that I just inserted. There's another way to do it, and we'll get to it in just a minute. But I'm going to go back to my worksheet, give myself some room to work. And what I'm going to do is I'm going to do another insert statement, but this time what I'm going to do is I'm going to insert null values. So I have a shorter insert statement, but you have to notice some difference. So I'm going to go ahead and just insert into customers, just like I did before. But after that insert command, I'm going to name the fields that I'm going to provide data for. So it should match up with my values. If I have 5 fields listed here, that means I'm going to have 5 values listed here. So 2, 3, 4, 5 is going to go into custom num. Ryan is going to go into first name. Reynolds is going to go into last name. Now the reason I chose these, if we go back up and look at our create statement, remember first name can't be null, last name can't be null. So in my insert statement, I have to have values for those, or I'm going to get a database error saying that I've messed up and that I'm trying to do something impossible. So I highlight my statement, I click run, and again, one more row is inserted. So if we go to the data grid and hit the refresh button, we now see Ryan Reynolds in our database with all of those null values. All right, so let's go ahead and use our first select statement. Now, if I want to see things, if I want to select records from the database, I can see all of the data at the same time, the same as clicking over to that data view. What I can do is I can use the command select, and you will become best friends with the select because a ton of what we're going to do throughout the semester will be a select statement. And we're going to put in the asterisk, and asterisk is substitution for select everything. And then we have a from statement. Now I am typing everything into, and I told you I wasn't going to type, I'm typing everything in capital letters. You don't have to. This is not case sensitive, so you don't need to worry about that. It's just kind of standard and a little bit easier to read. So with that highlighted, I click run, and notice down here my script output changes to query result, and you'll use this throughout the semester as you start getting a little bit more selective on what data you're pulling from the database. But this right here shows us the output. So if we had 57 records in here, I would have scroll bars here that would allow me to go look at all of that data. So select all from customers is a lot of times just a quick check to make sure that your data looks like it's supposed to. So far so good. We've created a table. We've inserted values in without null characters, and then we've done an insert statement that did have null fields, and we've looked at the results of our table. So we're going to look at a couple of different kind of editing things. If a customer updates data, or you made a mistake and you need to change something, you might need to update a row. If a customer leaves, or if somebody for some reason doesn't need to be in the database anymore, you can delete individual records. So we're going to take a look at that. So let's say that I moved. Right now I live on 123 Main Street. Let's say that I moved across the road to 124 Main Street, and I need to update that. So what you need to do is you need to tell the database what you're going to update, what table it's in, and then you're going to use the set command to set the field name equal to the new value. But you have to make sure that you do it on the right record. So you have to use a where clause, which is going to say where your criteria is met. And so let me just go ahead and bring in my update statement. So we're going to update the customers table. We're going to set the address field equal to our new value. Oh, I moved to 245 Main Street apparently. And then I'm going to say, but only do that, only change the address to 24 Main Street where the customer number is 1234. So that tells the database, go in, find the row where customer num is 1234, and in that row, change the address attribute to 245 Main Street. So when we update customers and we run that, we get that one row was updated. And we can do, since we don't have that many records, we can select all from customers, and we'll see that I now live at 245 Main Street instead of 123. Now, if for some reason I am no longer going to be a customer, we can go ahead and do the delete statement. And again, we're going to delete from the table, and we're going to set a criteria. So in this case, we're going to delete from the customer table where customer number is 1234. So it'll go in, it'll find the row where that criteria is met, and then it will delete that record. So I need a semicolon and highlight that, run that. Again, one row was deleted in our script output. And if we do another select all from customers, then we will see that Ryan Reynolds is the only person left in our database. So those are the basic commands that you're going to use for creating the table. From time to time, particularly if you're inheriting a new database and you want to see what the database looks like, another command that can be useful is to use the describe command and the name of the table that you want to describe. So when you run that, oops, I didn't run that. What it does is it gives you the name of the field, it gives you the null, and it gives you the data type. So again, that'll just give you a list of the columns, the characteristics, and the data type of that. Finally, when you're done, if you no longer need that table or you've made a mistake and you need to start over, what you can do is you can issue the drop table command. Drop table customers, and do that. Table customers was dropped. Now again, it's still showing up over here, and do know that when you delete that, it's obviously going to delete the data too, but we do our refresh and it shows that we're back to scratch. So in this example, in this homework, what you're going to do is you're going to load up the tables. Now, I provide those files for you in the course resources back in the intro module. They're .sql files. You can open them up in a text editor and you can copy and paste the code in here and run it, or you can do a file open and go and open up your SQL statement that you already have. But that's the intro really to our interface here, but also to our commands that we need to get started. In the next section, we're going to start pulling data out of our tables. We're going to do single table queries, and then we'll head on into the midterm.